Section 7.2, the quadratic formula. We will learn how to solve quadratics when they are not factorable, and if you would like to avoid completing the square, which was section 7.1. So our definition of the quadratic formula is the solutions of ax squared plus bx plus c equals 0 are given by x is equal to negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Now, to give you an idea of what we're doing, whenever we're asked to solve and we have a quadratic, it's always your x-intercepts. So we're trying to find x-intercepts, and there we have them. If we have a case where we have an I, meaning an imaginary number, meaning the square root of a negative, it just means our quadratic never does touch the x-axis, and therefore we do not have any x-intercepts. Example, solve 5x squared plus 8x minus 3 using the quadratic formula. We first find the standard form so we can label A, B, and C coefficients, meaning you first have to set it equal to 0. All right, so let's go ahead and add 3 to both sides so that we have 5x squared plus 8x plus 3 is equal to 0. Now we label our coefficients. I have A is equal to 5, B is equal to 8, and C is equal to 3. Now why do I need them? I need them because I need to use my quadratic formula. Now every time you use it, write it down. It'll help you remember. So that we have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so let's go ahead and just plug in these values. We have an a, a b, and a c. Let's plug them into our quadratic formula. So that we have x is equal to negative 8 plus or minus 8 squared minus 4 times a times c all over 2 times a. Okay, notice I carefully labeled all of my substitutions using parentheses so I don't make a silly mistake. All right, let's finish it off. A negative times 8 gives me negative 8 plus or minus the square root of 8 squared is 16 minus 4 times 5 is 20 and 20 times 3 is 60. All divided 2 times 5 is 10. Ooh, I did 8 times 2 instead of 8 squared. 8 squared is 64. So I had a little mistake there. I have negative 8 plus or minus 64 minus 60 is 4 divided by 10. I have negative 8 plus or minus the square root of 4 is 2 over 10. So let's finish it off. I have x is equal to 8 plus 2 divided by 10 and 8 minus 2 divided by 10. So I get x is equal to 8 plus 2 is 10, 10 divided by 10, and 8 minus 2 is 6, 6 over 10. And we can simplify them. So I have 1 and 3 over 5 for my answers for x. How to solve a quadratic. Check for the form x squared equals d. So before I start, these are all the ways to solve a quadratic, including what we learned in section 7.1. Back in chapter 4, we learned how to factor. This is it. So first, we want to see if we have the square root property. So meaning, do I have a variable squared equals a number or a product squared equals a number? If this is the case, our first step is to know that we can use the square root property. If not, try writing it in standard form and see what you have. If once you have it there, you can try factoring. And if it's not factorable or if factoring is too difficult, you can always use the quadratic formula. So these are all your methods. You can use your square root property, factoring, and quadratic formula. Although solutions of a quadratic equation cannot always be found by factoring, they can always be found using the quadratic formula. Alright, now let's just do some examples where you practice the quadratic formula. So make sure it's always set equal to 0. So let's go ahead and move the 3 over. So that I have 5x squared minus 8x minus 3 is equal to 0. And you always want x squared x in your number. Let's label our values. A, B, and C. And write them down. It might feel like a silly step, but it's so helpful. So A is 5, B is negative 8, and C is negative 3. Alright, before you begin, always write down your quadratic formula. We have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Alright, let's work it out. Use parentheses to avoid making a silly sign mistake. So that I have negative, my b is negative 8, plus or minus the square root of b squared, so I have negative 8 squared minus 4 times a times c, which is negative 3. All of that will be divided by 2 times a, and my a is 5. Ooh, I'm really happy I used parentheses because there are a lot of negatives here. I probably would have made a silly sign error. So negative 8 is positive 8, plus or minus the square root of. Negative 8 squared is positive 64, and negative times a negative is a positive. So I'll set up my sign first. 4 times 5 times 3 is 60. 4 times 5 is 20. 20 times 3 is 60. All divided by 10. Alright, so this is just like our last problem, but our signs were different. And now we have a whole different set of zeros. So I have x is equal to 8 plus or minus 64 plus 60. Well, 6 plus 6 is 12. So I have 124 divided by 10. And I'll let you finish it off. For the remainder of the problems, I'll work them out with you, but I'll let you finish them off. I don't think 124 is a perfect square. Well, let's just work it out. All right. So 124 is not a perfect square, so you have to think of numbers that multiply to give us 124 that are a perfect square. Let's start with 4, which is one of the smallest perfect squares we have. So can that be divided by 4? And we see that it can. So I have 8 plus or minus, and if we divide by 4, we're left with 4 times 31, all over 10. Now I can take the square root of 4, which is 2. So I'm going to write this on the side. I can take the square root of each one separately. The square root of 4 is 2. So I'm left with 2 square root of 31. X is equal to 8 plus or minus 2 square root of 31. Let's divide by 10. Now the 10 is dividing both of my numerators. So I'll draw a heart to help remember. So 8 divided by 10 is, well, it's a fraction that we have to simplify. So we get 4 over 5 plus or minus square root of 31 over 5. You can write them together or separately. You could have also thought about it as factoring the numerator and the denominator by a 2, by a greatest common factor. Alright, practice punching this in your calculator. You should get an answer of, so for the positive, we get 1.914, and for the negative, we get negative 0.314. Alright, let's go on to the next one. So let's first label A, B, and C. We have A, B, and C. My A is 1, my B is 1, and my C is 1. Let's go ahead and take the square root. So I'm going to write my square root formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I have negative b, negative, and my b is 1, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Alright, let's clean it up. We have x is equal to positive 1 plus or minus the square root of 1 minus 4 all over 2. So I have 1 plus or minus the square root of 1 minus 4 is negative 3 all over 2. Alright, so let's take the square root of a negative. Remember that results into I. Remember that the square root of negative 1 is just I. So if we ever have a negative, we just get rid of it by writing I. So that I have x is equal to 1 plus or minus I square root of 3 all over 2. And I can't divide the 2 evenly into my numerator, so I can just write it as 1 plus I square root of 3 over 2 and 1 minus I square root of 3 over 2. And there we have it. That's it for section 7.2, the quadratic formula. My best advice is to just practice it and be patient. Label your A, your B, and your C. That's always very helpful, and always write down your quadratic formula. All right, that's it for this section. Thank you.